Okay, let's do the next 20-second. Okay, 20-second first one. Okay, 20-second one, that is x raised to 5 minus cos x upon sin x. So this also is done using the normal method. Okay, so now you can consider this to be two functions which is in the quotient form, the quotient rule. So the quotient rule will be applied here. So this can be considered as u and this can be considered as v. Okay, so u by v. So we have the formula u by v whole dash derivative is equal to u dash v minus u v dash upon v square. Okay, so this is u. So x raised to 5 minus cos x whole dash, or we can write this on d by dx. Okay, and v as it is, that is sin x. Okay, minus u as it is now, x raised to 5 minus cos x in brackets. Okay, so because we have negative here, and v dash, that is d by dx of sin x. Okay, upon v square, that is sin square x. We can write sin square x or sin x whole square. Okay, this also sin x whole square, but not sin x square. Okay, this is different, this is angle. Okay, so sin square x or sin x whole square, both are same. Okay, we'll use this now here. So the derivative of x raised to 5. Okay, so you know this is in the form x raised to n, so this will be n into x raised to n minus 1. So 5 x raised to n minus 1. Now we are not splitting this inside. Okay, we'll just assume that this is inside d by dx of cos x. Okay, so 5 x raised to n minus 1 minus derivative of cos x is minus sin x. Okay, so this will become minus sin x. Okay, I'll write minus sin x and multiplied by sin x minus this one as it is, x raised to 5 minus cos x, derivative of sin x is cos x. Okay, upon sin square x, we will write sin x whole square here this time. Okay, so this will be 5x raised to 5x raised to 5 minus 1. Okay, so 5x raised to 4, 5 minus 1 is 4, and minus into minus will be plus sin x, and this sin x, okay, that will do later, sin x minus now let's multiply this inside. Okay, so x raised to 5 cos x minus cos square x. Okay, upon sin x whole square. Okay, so here also you have to multiply it inside, so it becomes 5 x raised to 4 sin x, and with this sin square x. So now let's open the brackets, so minus x raised to 5 cos x, minus into minus become plus cos square x. Okay, upon sin square x or sin x whole square. Now see, we'll write 5x raised to 4 sin x, and we'll write this one here, minus x raised to 5 cos x and plus sin square x plus cos square x upon sin square x. Okay, you see sin square x plus cos square x is equal to 1, so we can write this as, and see the highest power is written first. Okay, so we'll write minus x raised to 5 cos x, and next we'll write this one plus 5x raised to 4 sin x, and this is 1. Okay, so plus 1 upon sin square x. Okay, that's it, this is the answer given. Okay, now we'll do the next one, it is number 2, 22. What is 22? It is x plus cos x upon tan x. Okay, and again in the quotient form, that is u upon v. So we can write u dash v minus u v dash upon v square. Okay, so this is u and this is v. So u dash is on d by dx of x plus cos x multiplied by v, that is tan x, minus u as it is, so x plus cos x, v dash, that is d by dx of tan x upon tan square x or tan x whole square. Okay, so derivative of x is 1. Okay, 1 plus, and derivative of cos x is minus sin x. Okay, it will be minus sin x multiplied by tan x. So this will be minus x minus cos x. Derivative of tan x is secant square x. Okay, upon tan x whole square. Now let's multiply this in, it becomes tan x minus sin x tan x, and this becomes minus, let's multiply this first. Okay, x secant square x minus cos x secant square x upon tan x whole square. Now it becomes tan x minus sin x tan x. So multiplying the negative inside, opening the brackets, minus x secant square x, minus into minus become plus, cos x secant square x upon tan square x or tan x whole square. Okay, so this is the answer, I think. Let me see. 1 minus. Okay, in text it is up to here only. Okay, this is not given, so no need to do this. It's up to here only. Okay, and this is plus. Okay, this is it. This is the answer in the textbook. That's it.